This 5.1 worksheet key is just a couple problems for you to practice. So the first thing is they're asking us to find all 6 trig functions, and right now they're telling me that the sign is positive, and remember that sign is positive. It's my y value, so it's in the top 2 quadrants. And then this one right here is saying cosine is less than 0, which is negative. Cosine's your x, so it would be in those 2 quadrants. So what we're going to do is draw an xy axis, and I'm going to put a triangle in the second quadrant. So I come out from the origin, go back vertically to my x-axis, let's call it theta. I will label it with the 4/5 from my sine, so the opposite is 4, the hypotenuse is 3, and some of you might recognize that. Otherwise you have to do Pythagorean theorem, but the missing side is 3. In my diagram though, it's going to the left, so we have to make sure to put that negative sign on it. Now when I go find my 6 trig functions, I'm going to do sine, cosine, and tangent. So we'll do these first. Sine is given to us, 4/5, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now I do not like to write my negative sign on the bottom number, so either put it out front or put it on top. Alright, so then we're going to just flip all of our answers, and so the cosecant, secant, and cotangent. And so if you do the cosecant, that's 5/4. If you do the secant, that would be negative 5/3. And the last one would be negative 3/4. So just flip your answers there. Now in that second part, they're going to start asking us to do some of the simplifying techniques. Now there are multiple pathways through some of these, so the way that I do it might not be the way that you do it. But remember, we can refer back to this page. Erase some of this. You refer back here. These are things that you should have memorized. So the reciprocals, the quotient identities, sine over cosine, cosine over sine for tangent, cotangent, and your Pythagorean identities. So the idea would be, I would start by maybe saying, okay, well, if my secant squared is right here, another name for that is 1 plus tangent squared. When you look at that Pythagorean identity sheet, and we just have this tangent squared coming down here. And so if we take a look at that, basically you would say that these two things add up to 0, and we're left with a 1. Now in that next one, you might take that secant and write it as 1/cosine, and then you'd have sine of x times, and with that tangent we might write that as sine of x over cosine of x. Now you could write it 1/cotangent, that would be acceptable, but I'm going to go sine over cosine. And so then when you look at this, notice we have 2 common denominators, and so if you multiply these 2 things together, you're going to have a cosine of x on the bottom. You have a 1 from this numerator, but sine times sine would be sine squared. And then if you look at your Pythagorean identities again, the Pythagorean identity with 1 minus sine squared, you should have learned, was cosine squared. Now I'm going to go ahead and do this. I'm going to cross off because I have a cosine and a top and bottom. So when I do this, I'm not getting rid of everything because there were two of them on top, and so my final answer is just that cosine. Part C, you can save yourself a lot of time, and some of you might be looking at that Pythagorean identity. You might switch it out, but I'm going to factor the top into cosecant of x plus 1 and a cosecant of x minus 1, and that's all over cosecant of x minus 1. So again, I can just cross these two off because we're multiplying the top by that, and it's the whole thing on the bottom, and so my final answer would be cosecant of x plus 1. And then the last one, some of you are good at this, some of you are not. It's what I would call the factor by grouping technique. So watch how I do this. I have 3 secants and 2 secants, so I can take a secant squared of x from both of them. So that would be secant of x. There's an extra one left, but when you take both of them away from this one, you don't, you're not subtracting away, you're dividing it out. So secant divided by secant would be 1. And then in this term, there's really nothing that they have in common, so what I'm going to do is factor out a negative 1. Could be a positive 1, but I'm going to do the negative 1. So negative secant divided by negative 1 would be secant. 1, this 1 divided by this negative 1 would leave me with the negative 1. So that's why I chose to do the negative 1, because these two things are identical. So what I'm going to do is factor that out to the front. Now I don't bring both of them, it's just factoring it out. Since both terms have it, like this is AB, CB, so I'm just bringing the B out front. What would be behind here now is these two things. So that's secant squared of x minus 1. Now if you look at the Pythagorean identity, if you go to this one right here, and you take the 1 and you subtract it to that side, notice it's left with just tangent squared. So what I have here is secant of x minus 1 times tangent squared of x. And that would be the best answer.